Okay, hello. So this is the part where we're going to analyze our data. Before we do that, I want to kind of take a gander here at a couple of things. The first being how we actually calculate the concentration that we should have for each sample, okay? This is the concentration that we should have for each sample based off of the numbers that we're using, okay? In order to solve this, we know that we're starting out with a 7 micromolar solution of blue dye. And then what I'm going to do to calculate the rest of them is do this M1V1, M2V2 calculation. So the molarity times the volume of solution 1 is equal to the molarity times the volume of solution 2, okay? So the first thing I'm going to do is you always start with your stock as your starting concentration. So our starting concentration is 7.0 micromolar times, and in solution B, I'm using 8 milliliters of the stock solution. So I'm going to multiply that by 8. I'm going to set that equal to, I'm now trying to figure out the new micromolar concentration, and my solution is additive. So if I have 8 milliliters of the stock solution and 2 milliliters of water, that means my solution is 10 milliliters total. So when I solve for X, that means that the concentration of the B test tube is 5.6 micromolar. Okay. So you're going to fill that information in. You'll notice that I've already done the dilution ratio as well. And I went ahead and put the data in that we collected during the lab. The next thing you're going to do is carry that information over to a Google Sheet. Okay, so I have my solutions, I have the percent transmittance. I have to now solve for the transmittance and the absorbance and the concentration using Beer's law. Okay, so the first thing I'm going to do is get these out of percentages, and we know that to get things out of percentages, we divide by 100. So I'm going to go equals this number divided by 100, and I'm just going to hit enter. And just like we did before, I'm going to come up here and pull this down so it automatically fills in everything for me. You'll notice that for my blank, I did 100% transmittance because that means that 100% of the light transmitted through the machine because it was just distilled water, so no matter or no particles for it to bounce off of. Okay, now to figure out absorbance, we're going to negative log the transmittance because they're inversely related. Logarithmic, I can't say it. You know what I'm trying to say though. Okay, so we're going to go equals negative log, and I just type log and it brings it up for me. And then I'm going to click on my transmittance and hit enter. And then I'm going to do the same thing. I'm going to pull it down so that I have the absorbance for every single number or every single sample. There we go. Okay. And then concentration. We remember that in order to solve for concentration, so we have absorbance is equal to that epsilon times path length times concentration. Okay. Epsilon is also sometimes referred to as A. So to get C by itself, we have to divide both sides by epsilon and B. So our equation comes out to be concentration is equal to absorbance divided by epsilon and path length. Okay. We're going to use 130,000 for our epsilon for this one. That is a predetermined number that I was able to solve for you, so you don't have to. So I'm going to say equals, my absorbance is here, and I'm going to divide that by 130,000, 1, 2, 3, times, and then the path length, if you remember, is just 1 centimeter because of that cuvette. Enter. And then I'm going to pull it down. So now I have the concentration for every single one of my samples. So micromolar is -7. So if we go 1, 2, 3, 4, 5, 6, 7, this is basically saying 16 micromolar, okay, for solution A. So we're a little off there. But that's okay. We'll still be able to get some good data for our next part of our lab. The next thing you're going to do is you're going to plot concentration against all 3 of these, and then you're ultimately going to figure out which one you're going to use in order to figure out the concentration of blue dye won in this Gatorade, okay? So I want you to think about what information you can get in order to figure that out. So think about what we actually used in our first part of the lab, what we were recording, and see if that kind of helps you figure that out. So just for a reminder, I'll show you how to graph the first thing, and then you'll obviously be responsible for graphing everything else, and then explain why you are picking that graph to use to figure out the concentration of the Gatorade. So if we remember, concentration is going to go on the x-axis always because technically it's what we're controlling because we are making those solutions. So I'm going to highlight my column here. I'm going to do Control C and hold it, and then come over here and highlight %T. And then I'm going to go up to Insert, Chart. And then you have to remember that we have to change a couple of things when we're doing this, okay? So let me move me over here. So this is actually, we need a scatter plot. So I'm going to click on Chart Type, and I'm going to scroll down, click Scatter. Okay, and you'll notice concentration is on the x-axis. So what I'm going to do now is I'm going to give my axes some names. So I'm going to come down here on Customize. The vertical axis is the % transmission. The horizontal axis is my concentration. And then the title is, we're just going to do %T versus concentration. Okay, and you're going to do the same thing for each one. Now, what you're also going to want to do for each of these is to plot a line of best fit. And in order to do that, we're going to go back into Customize, and I'm going to click on Series, and then scroll all the way down and hit Trend Line. And now that I have trend line, no matter what information I get, I can use that trend line to then figure out the concentration, right? So let's say I take a sample of this and I read it and I get 75% transmittance. I can go here and go down and say that the concentration of the blue dye in this sample is 1 × 10⁻⁶ micromolar, okay? So you're responsible for the other two graphs. And then you have to remember that you're picking one graph to figure out the concentration of this. And if you pick one, it doesn't really matter because I'm going to give you all of the data necessary in order to solve for that. All right, thank you.